So today I'm taking a look at this Easy ACC power bank. This is, I think it's called the Mega Charge, but it's actually it's the PB16750 power bank. It's an interesting one for a couple of reasons, and I'll explain why. Let's get it out of the box first, shall we? Because I've already had it out of the box. It's just in there because I thought you might want to see what the box looked like. So this is it. Upside down, there we go. So it has this orange trim around the outside, which I think is pretty stylish, it's nice. And then we have these, let's zoom in and focus so you can see that. We've got these two USB outputs, one is black and one is green. Now nowhere in the manual, which I have just here, nowhere in the manual or on the website or anywhere does it say it's Quick Charge 3 compatible. However, if we have a look at these, can you read that? There we go. If we have a look at the output green at the bottom here, you can see that it says 5 to 6 volts, 3 amps, 6 to 9 volts at 2 amps, 9 to 12 volts at 1.5 amps. So that is actually the sort of quick charge specification. However, I don't know if it's communicating with the same sort of chip, the Qualcomm chip. So I will try and test that out. I don't know if I've got a device that's going to test out the Quick Charge 3, but for now I'm just happy with it being a power bank and having another interesting feature. And that is that it has two inputs here. It has one USB Type-C, probably not in focus, one USB Type-C and one normal micro USB. And they're both inputs. So you can charge this thing with two cables at once. You can charge it at a lot faster rate. Now, what does it say? Let's see if it says in the manual what how much faster you can charge it. Well, there's some specifications here. We can run through these quickly. So it's 16,750 milliamp hours or 60.8 watts. Now, I've tested that, and I'll tell you what that is in a minute, what it really is, because the capacity is just the batteries inside. It can have USB Type-C input at 5 volts, 3 amps, USB micro input at 5 volts and 2 amps, total input DC 5 amps. Now, I've tested that as well. It didn't quite come up as 5 amps, but it was high. And then the black output on here is 3 amps, and we've talked about the green one already. How to recharge your power bank. It says here that it will saves up to 60% of charging time. So it says it's going to be 60% more efficient. Now, I haven't quite tested it fully, and we'll get onto that in a minute, but I have tested the capacity. Now, I've been testing it with one of these. It's a USB load, it's adjustable. I've been running at 1.5 amps, and I went through and tested this for many hours. Now, I usually use a different power bank. Where did I put it? This is my preferential power bank. This is a 10,000 milliamp hour USB power bank, generic thing. You can pick them up for about £7, believe it or not. Now, it says it's 10,000 milliamp hour, but actually I get around 9,000 milliamp hour out of this. So below what it's stated on here, but they state lower, obviously state higher, than they just state the capacity of the batteries, not the output that you can get from it. I guess because that varies over time. So if I just plug this in, we'll be able to see what the results were. Let's zoom in. So those are the results from this power bank, from the Easy ACC. This is completely flat and will not, as far as I know, will not even allow this to light up. Oh yes, it will. Okay. So those were the results. We got 10,275 milliamp hours out of the 1,600-750 milliamp hour thing. Let's see if it. Well, it still let me draw 1.5 amps. Let's see how much we can draw from the, which one are we in, the green. So this one should be able to draw 3 amps at 5 volts. It's not going to. This thing is nearly flat. It's recovered a little bit from last night. It was going for Oh, there we go, it's gone now. So I'm going to plug it back into the other power bank. So it hadn't recovered very much. So it'd been going for 6 hours and 51 minutes, drawing 1.5 amps. So does that tally? 6.5, yeah, roughly. And so that's pretty good, isn't it? That's not terrible. If you imagine that quite a lot of these are a lot lower capacity, so I'm okay with that. I think it's lower than it should be, and perhaps 1.5 amps isn't a reasonable load over that length of time. So I will play with those figures, but the problem is with a power bank that's this large, I mean, how am I meant to test that without spending my entire life doing it? It's going to take a long time. So I think 1.5 amps is a reasonable test using one of these. And I got to 10,000 milliamp hours. Your mileage may vary, I guess. So let's have a look at charging this beast, shall we? It did come with some cables. These are the things that I didn't put in the box. Now, it came with 2 USB cables. It came with one Type-C and one micro USB. The micro USB, curiously, has a red thing in it, which, I mean, I love the look of. They sort of remind me of Anker cables a little bit. They've got the same kind of molding. They seem fairly high quality. When I plugged it into charge to test, it was working. So when I fully charged this before I did the test, I must stress that I fully charged it. It was carrying a good amount of current and the voltage was very stable and didn't drop an awful lot. I tested it with this just to see the voltage before resetting it. So I'll move on to the next test, which will be how much current is it going to charge at, and do we think we're going to be saving a lot of time by having the double port, which is really good because I use, let me just grab that actually. I use these Orki plugs. They're really great little plugs. They're not too expensive and they're high quality outputs. So you've got the full range across here. So you can get 2.1 amps. It might even be 2.4. It probably says on here somewhere. It is 2.4 amps each. And actually it's 6 amps max. So you can get 2.4 amps on 2 of them, but you can only get 6 amps out total. I use one of these all around my house. This is every charger that I have is now one of these 3-port ones. And so oftentimes I'm only using one. So for charging this thing, 2 ports is fine by me if it's going to charge it in a lot less time. So the 2 cables really handy and brilliant to come with as well, especially the Type-C, because my phone is a Type-C. So I'm hoping that its quick charge is going to work on my phone, but we'll find out about that. Right, so this power bank is now completely dead. So there's no power left in here. It won't activate. It won't light this up at all. Now I can make it light up by just plugging a power source into the charging point for a second and unplugging it, and it thinks it's been charged again. So it resets whatever flag is stopping this thing from turning on its output. But we're not going to do that because I know that basically it's hit the limit at which it's going to give out any more power. So I'm going to charge it up. I'm going to be using one of these Orki power supplies. These are 3-port power supplies. They're capable of kicking out 2.4 amps for each AI power. That's the green one in there. There's also an orange one. That is a quick charge 3 one, capable of kicking out 3 amps. Now I think the output is 4.8 amps max on these 2 AI ones and 3 amps on this one. So a lot. So it should be more than enough to take advantage of this dual power input. So let's plug this in. And we've got our USB Type-C cable. I'll throw that into the Quick Charge 3. And where's the other cable? On my lap. And these are the cables that came with it. So, oh, actually what we wanted to do as well, we wanted to pop these in here. So before I turn this off for good, we'll have one last look at the data that we had on here. So we had about 10,000 milliamp hours over about 6, almost 7 hours is what it kicked out from this using my 1.5 amp load. So let's reset that. There we go. And I don't have a second one of these to measure how much is going in, but I do have one of these charge doctors. So we'll be able to see how much is going in, and I'll use this to measure over time. So not great, because this one doesn't record anything, whereas this one records. This is a really fantastic one. I should get a couple more of those. So let's see what the voltage is at the moment. We've got 5.13 on our Quick Charge 3 output. I plugged in the wrong cable there. We've got on our top one 5.14, 13, basically exactly the same. Now let's plug these in. So this is the USB Type-C connector just here. So we're going to pop that one in first, and we won't see anything yet because I won't be looking at the displays. And then the last one is that one there. So this one has shot up now. I don't know if you can see that properly. Let's zoom in. So we've got on our first USB port, we've got a current of 1.25 amps. And then on our other one, I don't know if I'm going to be able to show it to you. Let's see if we can get it at the right angle. It's tough. No, I don't think I can. I'm just going to have to read it out to you. So it says 4.83 volts. This one's reading slightly higher than that, but this one's also drawing more current. So this one is currently pulling 2.25 amps. Now this, because it's Quick Charge 3, it sort of changes over time depending on how much the device asks for. Now the device appears to be smart in some way. So right now it's drawing 1.9. It's jumping up to 2.25. So it's jumping around a little bit. So this should charge in a fraction of the time that it normally takes. So let's see what it says in the data sheet. Right, I've just been through the little manual that came through it. It doesn't really say too much about how long it should take to charge at maximum speed. There's no actual listed number. It just says save up to 60% charging time. Now we're charging at roughly 3 amps. It did say that the inputs could be 3 amps on the Type-C and 2 amps on the micro USB, but whether or not it's actually asking for the right amount of current, I don't know, or whether the cables aren't up to it, or whether these are interfering. We're just not getting that kind of power out of the Orkey USB adapter still. Whether or not it's capable of that, I mean, it sort of suggests it is based on here, but we're only taking 1 amp out of one of the sockets down there on the micro USB, so who knows? But that might be because it's not high enough voltage, potentially, but they should work on voltages down to 4.5 volts, according to the USB spec. So yeah, there we go. Anyway, we're charging at 3 amps. So I'm not sure what the conversion factor is going to be in here, but that would mean that I expect it to be charged in around 3, 4, 5 hours. So what I'll do is, we've got a timer on here. I will look again in 5 hours. It is currently 5 minutes to 6 in the evening. So I might not make it 5 hours, I might make it 4, and then we'll see how close it is possibly, or how much energy we've put in. Energy? Someone needs to tell me what the difference is between that. See how many milliamp hours we've clocked up here. And then hopefully it will give us an indication as to whether this is actually charging any faster than normal. The 1.75 and an amp here, 3 amps, that's a fast charge. So even if it was on one cable, you'd be very happy with 3 amps going in. So I can already tell that it's going to be faster, it's going to be better. But we'll see if it just finishes in a remarkable amount of time, who knows. So in about 4 hours, I'll have another look, otherwise I'm going to bed. Right, so it's charged up now. It took a while, I fell asleep, so it's kind of the next day. I was meant to check it at about 10:30ish, but no, I nodded off. Anyway, 10:30 at night, that is. It wasn't like in the morning. So it luckily this thing records God, this cable's awkward. This thing records, God, it's hard to see. There we go. I don't know if it's in focus. Let's just try and make it in focus. That's as good as it's going to get. So it records the length of time this thing charged for. Now, I let it continue after I'd looked at it. So it actually was at 6 hours and 20 minutes. Was the last time that I looked at it before I fell asleep, and then it continued another 2 hours. Now the thing is, when it was on at 6 hours, it was only charging at something like 120 milliamps, so a really, really small amount. So it was doing its final charge, and all of the lights on the power bank were on, which meant that it was just getting those last couple of percent in, I imagine, which is a slow thing to do. So this charge doctor here was registering like 20 milliamps. This was at 120, so it wasn't taking a lot of charge. But anyway, you can see that just here we've got it registered, what is that, 9,348 milliamps. Now this charge doctor doesn't record how much it puts in, but this one does, and I know that charged at 2.2 amps for most of the time that it was charging. So that was putting the most amount of energy into this battery. And this one was charging at 1 amp. So we can sort of figure out how much that would have been if we'd just average it over that length of time. I use my handy dandy calculator. So if we do 9,348 divided by, let's say 2. So this one would have put in 4,674. And if I then add those two together, it's 14,000 milliamp hours that it put into the battery, into the battery box, which is quite a lot actually. So at 5 volts, it puts that much in, and then I guess, I mean, usually I expect it to have something like a 20% loss when charging these, 10 to 20% with heat lost when charging the battery, so you lose that much, but actually it's put in quite a lot. Yeah, I don't really understand that. Over 8 hours. Let's see what that would have been actually. So it's basically 1400 it's put into there, so that's the capacity we charged up, and the discharge capacity was, I can't remember now, in the region of 10,000, 12,000? It's in the video. So let's do 8 hours. So actually no, because it wasn't discharging for the same amount. I was going to sort of divide it down and see what average current was, but it doesn't matter. So what I'm going to do now is discharge this completely. We've already done a capacity test, so I'm going to discharge it completely and then charge it up with one of these connected. So we've done the fast charge test. It was basically done in about 6 hours, but it trickle charged the rest of the percentage. So I think it probably got to around 95% and then started charging very small amounts, and then it completely stopped. So when I got up this morning, it had completely stopped. But now we're on full. So we'll discharge it completely. I'll use this thing again. I'll whack it up to something like 2 amps. Should we pop this thing in again? I have to turn it over. And we'll reset that. And there we go. And we'll plug this thingy in. Okay, what are we drawing? We're currently on 1 amp. So let's, what are the maximums for this power bank actually? So on the outputs, the maximum on the black is 3 amps. Okay, we're on the green at the moment. The green is also, oh, it's also 3 amps, so it doesn't matter which one we're on. So let's just ramp this up a little bit. Oh, that's down. So you'll see we're just getting 4.65. Voltages on USB shouldn't really go below 4.5. And in fact, some things are quite picky and won't like it to be much below 5, but 4.46. I don't know how accurate this is. It seems to be recovering after I turn it up. So there's something in this which is helping it recover. So we're going to go up to 3. God, that's terrifying. Okay. I've never taken a power bank up to 3 amps before. But I suppose I've never had one that's able to do sort of quick charge rated power. I'm going to go right up to the line. Here we go. So at 4.362729, 4.3. That's a bit low for USB, honestly. So I wouldn't go quite up to 3 amps. I'd take 2.5. I'm sure it's probably fine. Let's drop back down to there. Yeah, 2.5. We're at like 4.5 roughly volts, and that's an acceptable range for that. So that's let's try it in the other jack and see if there's any difference. I think it's a symmetrical circuit, honestly, but one that's able to power the quick charge stuff from that one. So I imagine it's got roughly the same capabilities. Yeah, we've got the same voltage abilities. Let's try turning it up on here. At 281. No, look at that. The voltage is holding at 4.5. Let's try a bit more. Oh, don't want to shoot too far over 3 amps. No, you know what? The voltage on the black output here, the one that's not the quick charge alike, is actually holding a lot steadier. So 4.4647 is roughly 4.5, which is what's expected for the USB bus voltage. So let's plug it back into this other output and just see if it starts up any faster, any better. No, it's still like 10 millivolts below the other output. Interesting. Still, we'll discharge on this one, giving us a higher voltage, so it's probably better. And we'll take the output down to 2 amps. That's roughly 2 amps, isn't it? And then I'll run that down until it's empty. Now, it won't actually be empty. The battery sort of switches itself off. So there's still some capacity left in there, but it turns it down to a safe capacity. Now, I'll do that and then we'll charge it up through a single input. I'll probably choose the USB Type-C and we'll run it into the Orki power supply here, and then we'll be able to fully measure the amount that's going in, ignoring any of the weird stuff that goes on with these little meters with their reading accuracy and stuff. All right, it might be tomorrow. I actually thought we'd pause this test quickly. I mean, this is going to keep its values, but we'll just take that out. We've only been doing it for a little over an hour. But I wanted to test the Quick Charge 3 thing. So this has a quick charge. Well, it doesn't say explicitly that it's quick charge. Actually, it's getting quite warm at 2 amps there. But my phone is quick. God, I can't speak. In fact, we're going to take this out and put it in. Where's the quick charge one? So we can see how much current it's drawing at what voltage. It's not going to mess up my readings exactly, but we'll just plug this in the other way around and it should start to charge. Okay, it's not. Oh, there we go. I just had to press the button. So we're now charging. My phone has woken up and it should negotiate the charging level. I'm currently seeing 4.8 volts at 0.4 amps. Now my phone battery is down to 48%, so I would expect it to start charging a lot faster than that. It is in the right one, isn't it? Yeah, unless this cable's not a very good cable. I'll try another one. No, again, not charging at a great rate. Just in case this is messing with the result, we'll use the dumb charger, the dumb charge doctor, and see if this gives us a different result. So it's charging, again, it may be my phone. It is certainly Quick Charge 3 enabled, I don't know why it wouldn't be getting a lot more. I'm going to go and grab a different cable. Right, I've got a different cable. This one's an Anker cable. It is the one I use to charge my phone usually. This could be just a power only cable, in which case it's not a smart cable. So my phone might go, whoa, I can only draw 500 milliamps here. Which is entirely possible. Actually, we wanted to go through one of these. So let's try this one again first. And then I'm just going to plug it straight into my phone. And it's charging. 200 milliamps. Ah, there we go. So we're now at 2.56 amps. So that's good. That's exactly what I'm looking for. A high rate of charge at over 5 volts. That's good, look at that. So when I was using this before, I wasn't getting 5.45 volts at 2.56 amps. So it's doing something clever there. Now this phone doesn't need to request any more than that. It's at half charge, so if it was any less than that, it might ask for a higher voltage. But that looks okay to me. That's good. I'm just going to yeah, it drops straight down. I don't know whether that's because of the nature of the load or not. Or just because this is a smart load. So yeah, we dropped down to 6 volts. You saw it jump up a little bit there. So it's negotiating. And yeah, it's taking 6 volts. It's dropping down a bit because of the number of amps. Yeah, interesting. So it is quick charge. Let's see on smart chart, on the other smart socket. Now you see we're getting 0.93 amps here. We're just charging an amp. I don't know if it's going to change. We'll hold on to that for a second and just wait and see. Don't know if you can see that. It's a bit blurred out. No, we're at 4.6 volts and we're taking 600 milliamps. So it's not an intelligent port, whereas this one jump straight up. You've got 7 volts showed there, but we're going to be changing to the 6 volts and 2.56 amps. So that's pretty fantastic. Okay, I'll bung it now we've done that and assessed it for the quick charge. Right, my neighbour's playing guitar quite loudly, as you can hear. So I'm going to do a voiceover after the fact. So we've discharged this power bank completely. If I plug this into the Orki power supply, then you'll be able to see what we've discharged. So it's around 10,000 milliamps again, which is roughly the same as it was before. And it took 4 hours and 58 minutes. You can see that the power supply is completely discharged, the light's flashing there. So the charging cycle is at an end. So we've done it on a single port so that we could measure this more accurately rather than we had the charge doctor over here. Now it took 9 hours, 46 minutes to fully charge, and you can see that it took 14,426 milliamp hours. So that's how much has charged this battery. Now the stated capacity of this is 16,750. There's going to be some variance there. The variance isn't very much, in my opinion, for such a large capacity. Now, the output was fairly good. We're looking at around 10,000 milliamp hours on the 5 volt output, which is a nice amount. I mean, you'd expect some losses from the stated battery capacity to the output due to the way the boost converters work. Now, whether they've chosen some that work better at higher loads or lower loads, I don't know. But usually the case is with these boost circuits that they work better at higher loads, or at least there's like an area, a bit where it's like quite good at 1 amp, less good at 2 amps, but bad under 500 milliamps as well. So you have like a zone where it's better. Now, this thing is, I mean, it's the Easy ACA. So I'll put a link in the description for you. But I like it. I mean, it's better than my 10,000 milliamp hour power bank that I love, but I'll still keep using that. And I'll use it just because it's really simple. There's nothing to it. This one is a lot more complex, has other things going on. So if I just unplug this now, I wanted to show you that it stopped charging. But this one has those 2 inputs. It shortens the charge time significantly. So before it was about 6 hours, now it is 9 hours, 46 minutes it took. So that's a long time. Literally wasted my life charging and discharging this thing for this, what would be an ordinarily very simple review. However, it takes a long time with these larger capacity banks. So sometimes I might take it apart, but I mean, I don't know what I'll be looking at when I look in here, so there's no point me trying to take it apart and explain it. I do like it. It's also got a torch, I forgot to mention. They all have torches though. This one's very bright. Let me just turn these lights off so you can have a look. There we go. Yeah, look how bright, I mean, it's very bright, isn't it? But they all have these blue torches, don't they? So it's not really a big worry. Anyway, we'll leave it there. I think we've looked at it enough and you can see that the capacity is quite nice. Now, I'll put a link in the description if you want to pick one up. But otherwise, thanks a lot for watching. It was fun playing around with it, although not quite so fun charging, discharging, charging, discharging, charging, discharging. But yeah, it was nice to look at the capabilities of the thing and see, I mean, it forced me to look up things. So like, what are the good voltage ranges for the USB spec, which happens to be for 4.5 volts. I didn't know that. I had to look it up. All right, I will speak to you all soon.